Welcome to section 4.1 of our workbook. Hope you enjoyed our little intro fun about the imperial measurements. We're going to spend much more time than just that video talking about imperial measurements, especially in this chapter 4. But we're going to start with 4.1, and you'll actually see that we're started on page 80 of our workbook. That's where 4.1 starts. And I've decided to skip the warm-ups, so we're going to go straight just down to the bottom of page 80, which I'll zoom in on here. And it just says that units of imperial measurements. So we saw this in our last video there, but the imperial measurements have the measurements like inches, feet, yards, and miles. It's important to become familiar with the common abbreviations for these. So for inches, the abbreviation is IN, or more commonly, you have these two apostrophes, these double apostrophes. That's used for inches. Foot is FT, or feet, but the common abbreviation for that is one apostrophe. Yard, the abbreviation is YD. However, many people just write out yard. Same with mile or miles. People usually just write out miles instead of MI. You've probably seen this before when you're talking about someone's height. You know, someone might say they're 5'2", so they would write this 5, and the 1 tick is this 1 tick here for a foot, and the 2 ticks is the inches, so that's 5 feet 2 inches. Okay, so that's all you need to write on page 80. We're going to skip over to page 81 then, and look at things that you would use the metric or the imperial system. So we're kind of unique in Canada in that our official measurement is metric. However, because we have many influences with United States, and the construction industry still uses imperial measurements, we have to get comfortable with both metric and imperial. And so we find ourselves dancing back and forth between using metric and imperial. And sometimes it's more common to use the imperial measurements and sometimes it's more common to use metric. And that's something that we just got to get used to in Canada. So for example, height. If you look in our driver's license, our height is in centimeters or in meters, but when people talk to each other, we usually just refer to it as feet and inches. So I just got that example of someone who's 5'2" those are talking the imperial measurement of feet and inches. However, when we're talking driving, we see on the highway, we see kilometers per hour. It's 100 kilometers per hour. If we're in the States, or if you've made any trips to the States, you'll see that the highway postings there are in miles per hour. Your weight, again, we're still influenced by the imperial system there, and we usually weigh in pounds. You don't really hear us talking about how many kilograms we weigh. We usually talk about how many pounds we weigh. Gas, however, is in liters. If you see that on the sign, it's $1.10 per liter. In the States, they would say per gallon. Temperature, we're talking about the temperature outside, we talk in Celsius. Today was a lovely 22 Celsius. In the States, they talk Fahrenheit. However, ovens are in Fahrenheit because many of them are manufactured in the States, so they get used to that. So if you talk about warming your oven up to 400, they're talking about 400 Fahrenheit. Okay, so this is why we need to be comfortable with both metric and imperial measurements in our everyday lives. So this unit, though, we're going to spend most of our time talking about imperial measurements and talking about fractions of imperial measurements, particularly fractions of an inch. So today we're just going to get comfortable with breaking up 1 inch, and then in the next subsequent videos we'll talk about how to use multiple inches. But if you look at this diagram here, this diagram is meant to represent 1 inch. And of course, the diagram in your textbook is much, much bigger than 1 inch. That almost looks like 4 inches or almost 5 inches long. But it's representing 1 inch so that we can really scale down and see the smaller parts. So in the metric system, it's divided into 10 parts, but in the imperial measurements, it's divided into halves, or half of a half, or half of a half, half of a half. In this particular one, we're going to go as far as a half of a half of a half, which is 1/16. And many of your rulers actually go down to 1/16. Some go even smaller to 1/32. but we're only going to go down to 1/16. So you see then that this inch here is broken up into 16 parts, okay? And we're going to break all these down to the different subparts. But to do that, we're actually going to skip ahead and look at number 3 for a moment. So we're skipping ahead. We'll come back to number 2 in a second, because number 3 really talks about how going back and forth with fractions, remembering what those fractions are. So for example, a half of 1 is obviously 1/2. So 1 inch, a half of that is 1/2 inch. Okay, but if we wanted to talk about that in 16ths, we would remember our rules for fractions. So if we're converting 1/2 into something over 16, we ask, what did we multiply by 2 to get 16? Well, that would be a multiplied by 8. So whatever we do to the bottom fraction, we have to do to the top fraction. And so if this is times 8, then 1 times 8 is 8/16. And if we really think about this, if we had a piece of pie and we just cut it into a half, we would have 2 massive slices. But most pizzas are cut up into maybe 8ths or 16ths. A really large pizza would be cut into 16ths, and half of those pieces would be 8 pieces, 8/16, or 1/2. Okay. Then if we were looking at this in B, we have a half, and what's half of a half? Well, that's a quarter. Okay, 1/2 of a half is a quarter. And again, if we were talking about 16ths, we would say, what would we multiply by 4 to get 16? Well, that's a times 4 operation. So we would have to do the same on the top and times 4, and we get 4/16. Again, if we think of that pizza and we had 16 pieces, 4 of them would be a quarter of it. 8 of it would be half, and half of that is 4. And 4/16 is 1/4. Then if we cut in even further, half of a quarter, well, half of a quarter is an eighth. Okay, 1/8. And again, if we're converting to 16ths, we would say, well, what did I multiply by 8 to get 16? That's times 2. So I have to do the same to the top and times 2, and we get 2/16. Now you can really see it when we were talking about this. If you say 4/16 is a quarter and you want half of that, then that means that 2 slices would be half. 2/16 would be a half of a quarter, or 1/8. And then finally, if you wanted to cut it down even further, 1/8 is 1/16. Okay, and that gets all of the measurements down that we will see on our imperial ruler. Now, the reason I wanted to jump to number 3 first is because we also can reduce. So if I had 1/16, or sorry, this should be, yeah, half of that is 1/16. So if I had this 2/16 and I wanted to work backwards to get to 1/8, if I wanted to reduce this, I would do the opposite operation. So instead of multiplying, I'd be dividing by 2. So half of 16 is 8, and half of 2 is 1. So if you're reducing 16ths, you can divide the number by the top or the bottom. If I was reducing this 4/16 and I wanted to reduce it down to quarters, then I would say I would have to divide by 4. So 16 divided by 4 is 4, and 4 divided by 4 is 1. And similarly, if I was going from 16ths to halves, I would have to do the inverse of times 8. I would divide by 8. 16 divided by 8 is 2. 8 divided by 8 is 1. Okay, so going from these fractions and reducing will require some dividing, and that's why I wanted to look at this before we go to number 2. So let's go back to number 2, and in number 2, you'll then see that we're going to reduce each fraction in lowest terms. So we're going to take all of these and reduce them in lowest terms. So first I'm going to look at some of the big ones. So 0 is already in the lowest terms, and so is 1. Okay, so we have a 1 inch here. From here to here is 1 inch. And then you'll see that they've already divided this one into 1/2. And that's not a surprise, because if you look, it's exactly halfway between 0 and 1 is 1/2. Now, but if you actually looked at this fraction here, the 8/16, it does reduce to 1/2. What do I do from 16 to get down to 2? Well, I would divide by 8. So 16 divided by 8 is 2. And then the top is 8 divided by 8 is 1. Okay, so there you get that 1/2. And I could actually just group this and put it right over top of that so I can see there we got 0 and 1/2 and 1. Okay, all right. Now you'll see some other ones are done for us. Here's another one here, 1/8. That's this fraction reduced. Well, again, if I looked, there's a number that goes evenly into both of them if I divided it by 2. So 16 divided by 2 is 8, and 2 divided by 2 is 1. So this fraction is the same as 1/8. So I could take this fraction and bring it down here and say this is the 1/8 fraction. Okay. Similarly, here's another one that's reduced, 3/4. So where does that come from? Well, again, taking this and dividing by a common number. So both of those you could divide by 4. So 16 divided by 4 is 4, and 12 divided by 4 is 3, and so that gets reduced to 3/4. Okay, and you can see that right here. So I'm just going to put it right over top of it so you can see 3/4. Okay, but let's go off and reduce some of these other fractions. Okay, and you'll see how they match up with the ones that are already done. So 1/16, there's nothing that reduces into both. That's already in lowest terms, so that's just 1/16. 2/16 we've done is that. It's 1/8. 3/16, you can't divide 16 divided by 3. No, that doesn't divide evenly, so that's just going to be 3/16. Here's another one that does divide though. 4/16, if you divide both the top and the bottom by 4, 16 divided by 4 is 4, and 4 divided by 4 is 1. So here you get the fraction 1/4. This gets reduced down to 1/4. So I'm going to group that and put it right here so it kind of in line with this 3/4. All right. 5/16 is reduced down as far as we can go. 6/16, now I think you can divide the top and the bottom by 3. Or actually, no, just 2, I think. Yeah, 16 doesn't divide by 3. So if you divide by 2, 16 divided by 2 is 8. 6 divided by 2 is 3, and so that becomes 3/8. 7/16 is already reduced, and you can see there 8/16 we reduced to 1/2. 9/16 doesn't go any further. 10/16 you can divide both of those top and bottom by 2. So 8 divided by 2 is, or sorry, 16 divided by 2 is 8, and 10 divided by 2 is 5. So we got 5/8. This is reduced already, 11. This one we've already done. 13/16. 14/16, that one does reduce. Divide both the top and the bottom by 2. 16 divided by 2 is 8. 14 divided by 2 is 7. So that turns out to be 7/8. And 15/16 is already reduced. And then, of course, 16 over 16 is the same as 1. So that's a lot to take in right now, and don't panic if you didn't quite understand all of that, because we're going to break this up into smaller sections, and that's what the next page does. Okay, but there is that whole unit inch, 1 inch, broken up into all the different chunks, but we'll practice this a little bit more, so don't panic about that. You can just copy it down. Okay, so you've already done number 2, there's done number 3. So now let's move on to the next page. Flip over to page 82. And we're really going to be able to see all these little chunks a little bit more clearly instead of in that big picture. All right, so what fraction of 1 inch is indicated by each arrow? So you see in this case, it is in 16ths. Okay, you see all of these questions are asking for them in 16ths. And why is that? Well, because each of these ticks is 1/16th. In fact, there is 16 ticks between 0 and 1. And I'll prove it to you. We're going to count them. So there's 1 tick, 2 ticks, 3 ticks, 4 ticks, 5 ticks, 6 ticks, 7 ticks, 8 ticks. Okay, so 8 is half of 16, so we're halfway there. 9 ticks, 10 ticks, 11 ticks, 12 ticks, 13, 14, 15, and we get with 16 ticks. So you can see, in fact, the 0 to 1 is cut up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 ticks. And so reading these in 16ths is actually easy. We're just going to need to count each tick. So you see the arrows at the first one, so we must be at 1/16. That is 1/16th of an inch. Okay, so here's the 1 inch. This is 1/16th of an inch. It's one fraction, one part of it. It's like one little piece of pizza out of the 16 chunks. Okay, and then if I was looking at this one, it's pointing right to the 4, and I can count this 1, 2, 3, 4. I'm at 4/16. Keep counting 5, 6, 7, 8, 9, and then here I am at this one. It wants 10/16, and then this one here is 13/16. Okay, so writing in 16ths is actually pretty easy, but some of these uh, don't make more sense if they're reduced. So it says if any fraction is not in those lowest terms, reduce it and write that fraction beside it. Well, 1/16 is in its lowest term, but 4/16 can be reduced. Divide the top and the bottom by 4, and you get 1/4. 16 divided by 4 is 4, and 4 divided by 4 is 1. So this here is 4/16, but it's also 1/4, and that's 1/4 of an inch. All right. Let's talk about this one here, 10/16. Well, 10 and 16 are both even numbers. That means we can divide by 2. So if we divide them both by 2, we get 16 divided by 2 is 8, and 10 divided by 2 is 5. So this tick here, which was 10/16, can also be called 5/8, and that's 5/8 of an inch. Okay, it might be easier to count in 16ths and reduce it to 5/8. We're going to talk more about eighths and quarters in a moment. And then this 13/16 is as far as it'll go. Now, incidentally, if you wanted to talk here, this is 16. What is it? It's 16/16, but of course 16/16 is just 1. So we wouldn't say that this is 16/16. That's silly. We would just say it's 1 inch. All right, so we've reduced everything we can. We've talked in 16th for number 4. Number 5 talks in bigger measurements, bigger chunks. So we have the same diagram, the exact same diagram here between 0 and 1, but now the question asks us to talk in eighths. And that's because, sure, you could count all of the ticks, but there's 16 ticks. But if you looked at every other tick, you'd be talking in eighths. So there is 8, this whole inch can be broken up into 8 subsections. So let's watch and count. Here is 1/8. Now I'm going to skip the 16th, so this is 1/8. Skip that. 2/8, 3/8, 4, 5, 6, 7, 8. So you can see that this inches here can be broken into 8 chunks. So ignore the 16th and talk about these bigger chunks, 8 chunks. Okay, you can see those 8 pieces. And that makes it a little bit easier if I was counting in eighths. So this is my first chunk, or my first eighth. So this is 1/8. This is 1/16. This is 1/8. It's actually 2/16, which is the same as 1/8. But we're 1/8, 2/8, 3/8. So this is 3/8. And again, if we're counting, this is 4/8. 4 is halfway between 1 and 8, so that's good. So this is 4/8. 5, 6, this must be 6/8. 7, okay, so that's 7, and then of course that would be 8/8, but we would just write that as 1. So being able to see those eighths instead of just looking at the 16ths is a really handy thing. So be able to kind of ignore the 16ths and see this 1, 2, 3, 4, 5, 6, 7, 8, and be able to count in eighths. Some of these might be reduced. Now that's reduced, but this could go even further. So how does it reduce? Well, this actually reduces to, you can see that a 2 can divide evenly into both of these. So 8 divided by 2 is 4, and 6 divided by 2 is 3. So that means that this tick here, which is 6/8, can also be considered 3/4. And if you look carefully, you can actually see the quarter marks. So if I counted in eighths first in red, but if I counted in quarters, look at here, you can see I'm going to ignore all these eighths. This is 1/8, 2/8, which is the same as a quarter. So there's 1/4, 2/4 is halfway to 4, 3/4, and 4/4. All right, so you can also see the quarter measurements here. So that does make sense that this is 3/4, this blue one. The 6/8 changes to 3/4. And that's what we do in number 6. So if you skip to number 6, you'll be able to see that now it asks you to count in quarters. So here are those same quarter measurements. And here you kind of ignore all these, and you can just look and say 1/4, 2/4, 3/4, 4/4. And here's a great little way to do this. So I'm just going to blank this out for us. Okay, so watch what happens. So I'm just going to bring this up here. So I'm going to fill this in white. So it's like we're blanking it out. Okay, so look at that. If I ignored that and then ignored this section right here, and then ignored this section right here, and ignored this section right here, you can actually really see now the quarters. You see how it goes from 0 to 1, and this is 1/4, 2/4, 3/4. Oops, three quarters right there. Okay, so if you can imagine these these intervals in between as disappearing, you can clearly see 1/4, 2/4, 3/4, 4/4. Now, it's best that we actually keep these alive so we can see them. Okay, but it's a great little thing to imagine that they weren't there. So 1/4, 2/4, 3/4, 4/4 makes it much easier to make these reducing. So here's 1/4, there's 1/4, this is 2/4, this is 3/4, and of course this is 4/4, or 4/4, which is 1. 2/4 does reduce, and I bet you it's exactly 0 and 1. This is exactly 1/2 of the way below between, so I bet that this reduces to 1/2. Sure, 4 divided by 2 is 2, 2 divided by 2 is 1, and so we got 1/2. And you can even count halves. Look at this, 1/2, 2 halves. Okay, you can even go even further and ignore the whole thing and just say in halves. All right, so that's getting comfortable just going between 0 and 1 and counting in the 16ths, in the eighths, and the quarters, and even the halves. All right, so we're going to stop there. We're not going to do page 83. We're going to skip that because I'm more excited about moving on to section 4.2, which we will do in our next video. But great job today, and good luck with the rest of your quiz.